Question 4 is about the standard form for a circle. So this actually, it's in the functions chapter, but if you're really math savvy, you know a function is not actually, a circle is not actually a function because it doesn't pass the vertical line test. This was a good chapter to put it in, so just bear with me. And by the way, that's not something that's covered on the SAT if there's a vertical line test or whether or not something's a function. So it's still good practice. And it was just a nice place to put these equations of circles. I also want to remind you that I have a formula sheet in the appendix of this course, and the formula that you need here is on the sheet. So if we go down to the circles section, and it's right here at the bottom, I'm giving you the standard form of a circle here, where the center is HK. And this is not given to you in the reference information on the SAT. So this has got to be memorized, but it's very helpful. So make sure you have this one in that brain before you take the SAT for real. All right, so here it is, x minus h, where h is the x coordinate of the center, right? And because there's a minus in the formula, we're going to have some sign flipping action when we take the center and we put it into the standard form. So let me show you how it works on the question. All right, they gave us, well, let's write this down again. It's going to be x minus h squared plus y minus k. If this is reminding you of the Pythagorean theorem, that is not a coincidence. It is definitely based on that. Equals r squared. And we're going to plug in for the center a 5 for the h and a -2 for the y. And we're going to use that sign flipping action because there's minuses in the formula here. So it's going to be x minus 5 squared plus y plus 2 squared equals r squared. And I can see already that B and D are both wrong because they have the center incorrect for the equations. But I still have to figure out that whether it's A or C. So for that, I have to get the length of the radius. The best way to do that is to take these 2 points and use the distance formula. The distance formula is another formula that's there on the sheet for you. I'll just write it down here. In this case, D stands for distance. And it's the square root of x2 minus x1 squared plus y2 minus y1 squared. If that again looks like the Pythagorean theorem, is not a coincidence. Both the formula for a circle and the distance formula are derived from it. It's such an important theorem, and we're using 2 versions of it here in this question. So what I'm going to do is x2 is going to be r9. And actually, I'm not going to call this D anymore because it really is the radius of my circle. So I'll use D here because it's the distance formula. But now that I'm plugging in information from this question, let's change it to radius. I don't want you to mix up D and diameter. That's why I wanted to change the letter on you. So let's see here. 9 minus 5 is 4. And -5 minus -2 is going to be 3. I already know this is going to be 5 because of the 3, 4, 5 right triangle, but I'll show you the steps. That's a 16 plus 9, the square root of 25. And yet we do get 5. Now watch out, this is a trap. Because remember, in the equation, you don't put r, you put r squared. So we're actually going to go backwards to that 25. We're going to take the 5 and we're going to square it back. C is the correct answer here. So be careful when you're using this formula. Don't forget to square your radius at the end. And I'm almost, every time I've seen this question on the SAT, there's been this trap here, hoping that you're going to forget to square your radius. So if you really had to guess, I'd always guess a number like the bigger number on the right. There's something that has a squared value in it. I prefer if you don't guess though. I prefer if you actually calculate it so you know for sure that you got it right.